Hello friends, सबको नमस्ते. So today in this video we will create a pothole image segmentation model using a U-Net ResNet34 as a backbone. Let me show you the dataset. Okay, we have a three test, train, and valid. Let me show you the data.txt file. We have only one class pothole. Okay, and this is, you can say, a YML file. Now see this. In this data set, we do not have a mask images. Instead of that, we have a labels which contain the coordinates of the segmentation area. See, let me show you that how the labels look like. Okay, you can see that this is a, you can say this is a class label. Okay, and entire this, not this till here. Till here you can say uh, it is a coordinates of the segmented area of the pothole. Okay, you can say this is x1 y1 x2 y2 x3 y3. This is the coordinates of the segmented area of the pothole. Now we have to use this coordinates to make a segmented image. Okay, so let me come back. Same for the test and train, but in test we do not have a, I think so we do not have a labels, just we have a pothole images. Okay, now this is a Jupyter file which I will explain you, and this is a weights which is trained on 50 epochs. Okay, this is a helping code if it is necessary to help. This is a helping code which is made by me for explanation, but if I will able to explain you in a Google Colab itself, though I would do not use it. So let me open it in a Google Colab Jupyter file. I'll already open it, and let me show you how you can connect your Google Drive with the Google Colab. Just copy the link, make sure that it is stick on the anyone with the link. Let me cross it. So run this cell. It will download the JDown library, which is useful for connection of Google Drive with the Google Colab. Run this, and one thing I want to say that just copy that shared link and keep this part only till the slash and till here. This is act as a unique ID of your uh, dataset, which is uploaded by you in a Google Drive, and just run it. First thing you can see that your portal zip will download it, and then you can unzip it. When you will get unzip, you will get this dataset with all this text directories and all this. Okay, let me close it. And one more thing, this is a library which is used by me, segmentation-models-pytorch, for uploading the model which is required by us to for the segmentation. And these are the libraries which is used for training and segmentation, all things. Okay, we are also using a learning scheduler in this, and this is the directories where the images and labels is present. And when you will run it, images mask, actually it is not images mask, it is images labels. We do not have a mask images. We are this time we have a annotation details labels. But we want to check one thing, that number of images of number of images in image directory and the label directory should be same. Otherwise during training it will throw an error, because it says that for particular images mass labels is not present, for particular labels image is not present. So to avoid this image these errors, you have to make sure that images and labels it have equal number of uh, images in directory. Okay, see, let me, before that I will explain you the cell. Just this is a helping code by my side for explanation. Before that, let me show you one thing. This is directories. This is a list of, just make the list of all the images present in the directory. Flotation, where I'm representing the entire image, entire flotation with subplots. Axis here is in a 2D format. When I will use variable, it is in a 1D format. I convert this in a 1D format just for the ease of iteration to put the subplots. 4 by 4, we are plotting 16 imaging, means 4 rows, 4 columns. Figure size will 2 divided by 18. Alpha here is just act as a transparency which is required during segmentation. We have only Pothole as a class name, and for that we are using 0 as a class index for that. Okay, there's a, you can say it is useful for creating the blended image where the image is there and also the segmented part is there. Okay, so let me first show you the result of it. I did about 16 random choice of image file name, image path will created by just pass the image directory and image, and annotation path because the file name will be remain same but the extension change. So just change the extension from jpg to txt, you will get an annotation path, and then read the image path image in a and convert it into rgb to bgr to rgb because cb to read image into bgr format. Now just if annotation path annotation directory or annotation file is exist, just give that annotation file to the draw polygon with image, and it will return the blended image. You will plot it. This is something. Okay, okay, wait for a minute. Let me pause it. Let me comment all this print statement. I write the statement just for the explanation. So wait, I will explain you each thing. But before that, let me show you the result of it. See the result. It's working good. Okay. Now let me show you what I want to explain you. I just want to iterate for one image only, so that I can explain you everything in detail, and then let me uncomment them. See here line, what is line representing here? Line will represent me this thing. This is its line start from 0 and it to here. Okay, and it to here, because not here, and it to here, this and it to here, because next class label start from 0 and this. Okay, so first line will be this. So when you will fetch this line, you will see that first variable is a first lines will be a class label and others where are the coordinates. Okay, but this time line, whenever iterating over the line, it is in a string format, not in a format that we can easily fetch the details. So when we get image and annotation, we will first overlay. What is the use of overlay? Why I am using it? See, just overlay is you can say a 3D dimension of same height and weight of the image, where we plot segmentation area with the color, means it's highlight the area where the segmentation has to be performed. Okay, with 3D means with 3D channels, RGB. But what is mask? Mask is actually a 2D array. You can say it's a grayscale format, and the shape of that mask will be same image dot shape dot to call to this and to what it means. It will go. It will give me the values from 0 index to 1 index. Okay, height and width. Okay, so mask is a 2D array with of height of image and width of image. We created it. Now let me define the meaning of using of overlay and mask. See, listen to my words. Overlay, it's used to highlight the segmented area with color, means RGB, red channel, green channel, blue channel. Mask is actually a grayscale format image, which you can say which only highlight image in overlay. It's a copy of image, so all area will be there, but segmented area will get highlighted with the color. We are filled with color. But mask, it actually in mask it is a grayscale which tells us that on which portion we have to highlight, on which portion we have to highlight. Okay, mask tell us on which portion we have to highlight. Now we open this annotation file with reading mode. Here, what I already told you, that when we iterate over this if file, first line will give me this thing, complete complete class label with coordinates values. Now to easily convert this string format into a list format, we use strip.split. It give me the list format. You can see that after using that line, it's converted into a list format. Okay, now class id class id in data, first value is a class id only. I already told you 0. Now let me show you the use of this. NP array data10 data type. Okay, reshape. What is happening here from here to here? Okay, we already know that data is a list which contain label and the coordinates. Let's assume these are the coordinates values. Okay, now let me show you that what is the use of np0. First, data one, this two dots and this. What is meaning of this? Means it will pass all the values except the first value. Means it will skip this label part and give me all values other than first part. Okay, and why we are using it? Because we have to create the points like x1 y1 x2 y2. This way we have to plot the things. Okay, that's why. Now the type of that is float 32 and float 32. What is the meaning of reshape -1 here is will means numpy automatically select how many rows has to be performed, how many rows has to be there. And see, what is meaning of 2 means here is it should be in when we create this point, it should be have two column x1 and y1. So column represented by 2 and -1 means it indicate the number that you have to automatically select how many rows has to perform. So let me run this. 1 2 3 4 5 6. You can see 1 2 3 4. It's give me the points to the array x1 y1 x2 y2. And see, what's the use of this? Means I want x1 column I want. So I want x1 column. For that I just points 2 dots comma 0. It give me x column 1 1 3 5 1 3 5, y2 column 1 y column 2 4 6. This way we I fetching the x column and y column. Why I'm fetching this? You can see that these coordinates values are in a normalized form, but for plotation I have to unnormalize them. So for that I am just multiplying each value with w. You can already know that for x coordinate we have to multiply with width, and for the y coordinate we have to multiply with height. That's why I am normalize them. After that I just convert that into a int32. Now what overlay? Just this. We'll fill polygon. Fill poly. Will fill the polygon on the overlay with just pass the points, and class color will be class id. Okay, now fill polygon with the mask. Now just after using the cb2 add bit, it will give me the blended image. Now one more thing, let me show you what is happening. Now let first it has to return me the overlay. So I want to show you that how the overlay look like. See, this is the overlay, but segmented area is there, but transparency is not there. Okay, so to add the transparency in the image, we have to use this add weight function. Now see, I already told you that what is the already said you what is the use of overlay, just by giving the example that we can easily by using the fill polygon we can easily fill the color in the particular points coordinates, but we do not get the transparency. To get the transparency we use now we have to fill the mask. Now let me run it and show you how the mask look like. See, mask, it's look like no. I already told you that if you want to display grayscale image. For I am sure you have to use gray because default color map is of this matplot is something different. Okay, so for that we have to use gray here. Now it will display me the grayscale image properly. See, okay, now it's displaying me that now you will get confused that when I will on first iteration at that time the uh, image is different, and now the annotation is different because this is happening because you can see that at each iteration image changes because I randomly select the image. Okay, so if suppose I select only one image. mm, okay, no need of this. So see, I selected only one image. Now it will not select random image so that you will not get confused that after each iteration the image changes. So this is a overlay. You can see that transparency is not there. Now let me show you the mask image, how the mask image look like. See the mask image. It's only tell me that where you have to add the segmentation. Okay, so one let me blend dead image. Okay, now listen to my words. Overlay is the, you can say, is a particular, it is an image where the segmentation is applied but there is no transparency. Okay, mask is a grayscale image which highlight the segmented area with white color and other area will be black color. It tells us that where the segmentation has to be applied, but we have to combine with this both things in one so that we get the image with transparency. Okay, because ultimately we want transparency also in the image. That's why we first create an overlay with point, just pass the points with class color, and blended image, just make the image copy and just pass this cb2 add bit is give me image, blended image 1 minus alpha overlay alpha 0 first image, just pass the image 1 minus alpha, you can say 0.5 because alpha initial value 0.5, overlay, just pass the overlay alpha 0, and you can get the blended image. Now I do not want this, I want transparent images. Okay, so let me run this now. Oh, I think so. I applied the break. See that you get the image with transparency. It's just more segmented one. If just I will use overlay, it does not have a transparency and it also does not look good. Okay, so just copy this and then break this, break. We do not want break. We want a complete segmented image. Oh, uncomment this. I don't want this. Comment. Now run this. See, now something you can say that now we have a transparent image. You can easily see that with particular where the you can say where the pothole is there and how it's look like. Okay, if suppose there is no transparency, I will just use overlay. It's not look good. Now we have to load the model. First is torch.coda.available. It tells us whether we are using CPU or GPU. According to that, we have to make models and other things. All things have to be on the same device. That's why we make a one device variable and pass this method. We are now loaded the U-Net pretrained model with backbone ResNet34. In channel means we are passing the RGB format images, and classes too, that we have only two classes, Pothole and the pothole and the background. Now you will get confused that we have only one classes why the background is included. This is because we are using pre-trained model, and when the model is pre-trained, zero index value is always fixed for the background, always fixed for the background. So we have to include that part. Okay. Now model.device, and let me run this. It will now download the weights and we get the model ready. Now this is data class index. This is a Pothole class, segmentation class, which is held by the data loader, which helps the data loader to load the data set. Okay. So image directory, annotation directory, image size will be 224 and transformed. Okay. And image directory, initialize them, image file name, annotation file name, image size, transform, class table will be background and pothole. Okay. It gave me how many number of images which we are using for class or for segmentation for training. Now first get the image path, now then annotation part. IDX, I already told, in all my videos I told you that IDX is just to fetch the files, fetch the file name in the directory. Okay. Index value can is act as an index value. Okay, fetch this annotation file name. Now read the image and convert that into RGB, because CB2 read image into BGR format. Image shape HW. Why we are needed it? Just to unnormalize pixels values. Mask and zeros of height and width. I already told you that we have to create the mask just for that. Just it's give me the detail that we have to upload. We have to apply the segmentation and the whole things from whole things. I have explained you everything here. Okay. So don't get confused. After getting the mask, here we are not using the overlay. We are not saving to fill polypi overlay. Why? Because model had to predict the mask, not the overlay. We have to predict the mask. So that's why we are just we are just filling the fill poly with the mask only. And see in this when we are using this, we are filling the points inside the points value with 255 in white color, but here we are filling it with the filling with one presenting here is the pothole index value. Pothole index value is 1, that's why we are using here 1. Means fill all the area inside the points, fill that area with the 1 pixels value. Now resize them and then just add transform and any documentation in this if it is there, and then just return that image and mask. We have a transform, size and normalize them. Okay, convert them into two tensor. These are directories of validation tree. Now first create an object, and according to the parameters pass the directories, image mask, train mask, transform. And see one more thing here, we are not passing the image size because image size default value is always already a 224 into 224. Okay, so you don't need to pass that again and again. And train loader, it will using a data loader, we have to create a train loader. Just pass that class object, batch size will be 8, shuffle will be true, drop last. What is the drop last? Here is drop last is will drop the last batch. Okay, here shuffle will be false because during evaluation we do not need any shuffling of the data set. We are just there at that evaluation time. We are not updating the weights, we are just testing the model, how the model is performing on unseen data set. The loss which we are using is cross entropy loss. Optimizer which we are using is Adam. Just run this. Now let me check how many batches we have, how many number of images for validation and train we have. We have for train dataset we have 720 images, for validation dataset 60 images. Val loader have 8 batches and train loader had 90 batches, and each batch contain 8 images. Now we have to move to let me first run it. I want to run it for 10 epoch only because I want to complete this complete it. Okay, so let's get started. So this is a scheduler. This batch loss, because why we are batch loss is initially it's infinite because we have to save the model whose validation loss is less. Okay, same model path will be best model, epoch will be 10. We are using LR scheduler, cosine angle. Okay, warm restart. It's T03, T mult 1, and ETA means 0.6. Okay. So here T0 means after every third epoch, learning rate value will get a decrease, or you can say after every third epoch, initial learning rate value will come up. Okay, and initial value come back, and during learning rate scheduler, minimum learning rate value will be this 1e/6. For your better explanation, I come back write this example. If suppose initial value is 0.01, it will decrease to this, then decrease to this, means minimum learning rate value till minimum learning rate will decrease, and then after that it will restart with initial value after third epoch. This is the meaning of T0. And T mult 1 means after, let's suppose if we do not want, if I will write to here, it will the length of our restart you will be increase. If suppose I will write 2, then after 6 epochs restart again, means learning rate will be initialized with 0.001, the initial learning rate value which we have used. Okay, so let me come to my code explanation. This is the epoch learning rate. Now we are iterating epoch. Model is in a training mode, means updation of weight size to performed here. The epoch train loss, just in this way you can get the average learning rate, average loss at loss of the batches which we have. So iterate over the train load, make sure that image and master will be on the same device. Optimize the zero gate. Use of this is that to make the gradient value 0, because if we do not use that, the gradient value from the previous is accumulated to a current gradient, and it will affect the updation of the weights. Output on will just pass the images, and you will, after pass it, will get the out prediction. You will pass this through a criterion. You will get the loss. A loss dot backward, basically it will it will make a calculation of the weights values using the loss, and optimizers or dot step basically update the weights values. After that, you will store all the batch iteration loss in the epoch train loss. After that, you will calculate the average train loss, and uh, you can print the masses what is the train loss. Now the model is in evaluation mode. Same thing happening here. Just calculate the solution, calculate the, and you can say calculate the loss and print it here. The difference in training and evaluation is just the line of this line and this line, and meaning of this two line is same, that there is no updation of weights has to be performed here. Now scheduler step, the learning rate scheduler, that if our average best loss is less than best loss, we have to save that that model, and also update the best loss. Okay, best load value. Now you can see that our training of tan epoch is completed. The last validation loss is 0.16. Now we can use this model for prediction. See, our model is predicting good. Now let me explain you one thing what is happening here. There is something difference in the testing time. Some line is different. See, this line is same till here. Now we're loading the model is in a same device, evaluation mode, test trajectory which contain the images. Alpha is, I will tell you what is the meaning of this, and see what is transform. Because all the preprocessing which we had applied to the image during training has to perform also on a testing time, but do not include all other things, rotation, flip, horizontal flip. This is not necessary. Only the resize, tensor, and if suppose normalization is there, you can add that. Now we are iterating 8 times. Thus create the image path, open that image and convert it RGB. Why I used convert RGB? Because it is not sometimes it possible that images present in a text directory might be a grayscale image. So during testing time it will throw an error. So before that only we can convert that into RGB. If suppose we are passing the opening the RGB image, so it does not affect that. Now we have applied a transform to is. What is use of nsqueeze? Nsqueeze just to add a batch dimension into the image, because during test training time we passing the image into a batch format. So same format we have to apply during testing also. Okay, bit torch no grid. I told you meaning of that. Just pass the images. predicted mask, you will get a predicted mask just torch argument dot squeeze 0 dimension 0. What is your CPU? At this time, I don't want that my predicted mask should be on a GPU device. So I want that to it should be on a CPU. So that's why I'm using it as a CPU. Now, what is the use of NumPy here? NumPy is basically, you can say that when I will use the transform on the images, the output of the model prediction is in a tensor format. So I have to convert the tensor format into a NumPy format. That's why I'm using a NumPy. And predicted mass is a grayscale format. Okay, of height and width of the height and width is different, maybe different. Now to get the height and predicted mass of same height and width of the images, we have to resize it, but just pass the original width and height, and internearest means the pixel value which is not filled can be filled with nearest pixel value. Okay, now for this calculation, I want images, overlay, and marks should be in a NumPy format. That's why I convert the image into a NumPy format. Now overlay, I already told you that overlay is, you can see our image with the other where the segmented area is highlighted with the color, but transparency is not there. Okay, so for that, you can see that I loop over the class color. We get a mask boolean here. It is necessary that you will get after using this. After this, when you will use this line, mask is equal to class ID. It converts because mask basically give me 0 or 1 numpy array. Okay, one where there is 1 in a mask, you can say that at that portion segmentation has to be performed. So where there is a class ID will be there in a mask, it will say that particular area will be true and all the other area will be false. Means it'll give me the boolean 2D array where 1 represented by true and false and 0 represented by false. Because during during this manual computation, you have to pass the boolean 2D array. Otherwise, if you just pass the mask, it will throw an error. It will does not throw the error, but computation will be more, or sometimes GPU will crash. So that's why we have to pass the boolean 2D error. Now what is the use of 3 here? 3 is representing the channel, RGB channel. Okay, now if C is equal to 0, we will get the red channel. And after getting the red channel, only change those pixel values where there is true in the 2D area, 2D format. Because when we are iterating at 3 here till when I'm getting a red channel, their red channel is also in a 2D format, and this class mask, boolean class mask, is also in 2D format. So it will just when there's both is in a 2D format, you can say that where there is a true in a class mask, those pixel value will change into color C. If C is equal to 0, color C 0 value will be color C 0 value, what is there? 255. Color C 0 value will be 255, 1 value 255, and 2 value 0. Okay, this way overlay values overlay changes, and you will get it. Okay, it means basically it highlights the segmented area will get colored, but transparency is not there. Okay, now to add a transparency to get a blended image, we again iterate over it, and we have to use same 3. Just make the copy of the image, blended image, and convert mask is equal to 1. Mask is equal. I already told you that you have to pass the boolean 2D array. When you use mask is equal to 1, means it generate the 2D boolean array and convert all the pixels values where there is true, where there is 1 it convert to true, and where there is 0 it's convert to false. This way you will get the boolean 2D array and just pass this. Okay, now here calculation is performing. First it will fetch the uh, suppose C is equal to 0, it will fetch the red region, and same for the overlay, fetch the red channel, and mass is equal to 1. You will get the change the boolean to the array. Now you will get confused how the calculation is performing. So wait for the 1 minute. I will come back with the proper explanation of it so that you will not get confused. See this. Suppose this is the image and this is a red channel, green channel and blue channel of the image, and this is the red and green channel, blue channel of the overlay. Now this is a mask which we are using, and when we using mask is equal to mask is equal to is equal to 1, you will get this class mask, okay, where all the values where 1 is there, true will be represented. Okay, let me make it white here. This. Okay, now see this. If suppose C value is 0, suppose C value is there. When we use 3 dot comma C, you will get a red channel. So this is a red channel of image. Overlay 3 dot comma C, you will get the overlay red channel. And after that, you see that you are multiplying with 1 minus alpha, and alpha initial value is 0.5. 1 minus 0.5, 0.5. 0.5 is actually a half. So it's change only those values where is true is represented by class mask. So true is represented by at this place 0, nothing change. True, nothing change. Here true 255. My means 255 divided by 2, you will get 127.5. True 120 divided by 2, 64. Nothing on other pixels value will not get affected by this. Now same for the overlay. Change all the values where there is true. 250 means 255 divided by 2, you will get 127.5, 127.5. Okay, you will get this. And when you add this both, you will get this is, and this is a red channel of the blended image. Okay, same way you will get the green channel, blue channel of the blended image, and you will see that 255, 127, 125, 255, 127, 127. 255 0 255 255 0 255 and 191 64 192 191 64 194 192. This way you will get a blended image with the transparency. Okay, so this is happening manual calculation. You can see that how the model is performing. It's performing pretty good, well. Okay, so my explanation is completed. Please like, share and subscribe my video, so it could motivate me to make more videos like this, where I will explain you deeper knowledge of each line. Like this, I have explained you why you have used CPU, numpy, and I also explain you how you can get the this overlay and polygons. Okay, and suppose data set is different, how you can use this. Okay, if this type of explanation you want, please like, share and subscribe. Thanks to all. Thank you.